Hello, I'm going to show you how to work with for loops in Python. So we want to do that by means of example. And the example I'm going to use is given a number of fragments of a peptide, calculate the total number of amino acids in that peptide. It's iterative because we have multiple fragments, and that's why it's advantageous to use a for loop. So I start by getting an example of an array that contains information about a couple of fragments contained in a peptide. If I want to see what is contained in that array, the variable is called fragments. I can just type its name in JupyterLab and I can see it's surrounded by square brackets indicating that it's contained in a list. So each of the items in that list is a sequence of amino acids. It's a string denoted by single quotes, and this is what we want to work on. First question we need to answer is, how many fragments are there? How do we do that? We use len, len, to denote the length of an object. And if we, as an argument, put in fragments, then length of fragments gives us 3, and we can see that there are 3 fragments in this particular peptide. You also need to access each of the items individually to find out how many amino acids there are. So length can be used, but instead of using the length of the whole array, the whole fragments, we want to see what each item is. How do we access an item of an array? We give its index. So if we want to see the first item, its index is 0, zero-based language. And so if we take len of fragment 0, the output will be 4. It's 4 amino acids, MAPR, 4 characters in that string. And so on, because we would have to do it repetitively to find out the length of each of the fragments. This is a thing that can be shortcut by using a for loop. So let's start by looking at the syntax of a for loop, and it's like this. You start with for, and then you invent a name, which I call fragment, so that refers now to the item of a list. Each fragment in which array? Which array do we want to go through? Well, we want to go through the array fragments, so the one that contains all the fragments. And we finish the statement with a colon, which means now start putting in the code that you want executed. For space fragment, which is something that I just invented, within the list, which is called fragments, which is predefined, which you need to have there beforehand. Okay, now we need to access the things that are in that list, so the items of the list, and we gave it the name fragment, singular, so we can, for example, print it. So print fragment means give me the output in each of the steps of that iteration. Give me the output of that item that you currently hold. And if we outdent, then the for loop is finished. There's no need to type end or anything, and we can execute the code and see the result. Each of the fragments in that list was accessed. It's printed as an amino acid sequence, and that finishes the task. So that works. We can build on this code, copy and paste in a new cell, and now we build on it in which way. Now we know that fragment is the right thing that we wanted to have. We can, of course, check its length. So len fragment is what we need. We want to know the number of amino acids, and to work with it, we can assign it to a variable. And the variable say length of the fragment, and it's this. And having the number of amino acids in each fragment, you can of course also display it, so adding it as another item to that print list. If we now execute the code, we can see the sequence of amino acids followed by the number of amino acids in that specific fragment, and it's just what we want. So given this intermediate result, how can we use it to now calculate the length of the whole peptide that we have in terms of its fragments? And the answer is you define a new variable. This is what you want to have as a result. And this is maybe length of that peptide. It's a singlet, one peptide. And you assign it the value 0 because initially you know nothing about it. And once you have calculated the length of a fragment, starting with the first one, you can say that the length of that peptide is whatever it was before, and you add to it the length of that fragment that you currently hold in hand. So each time you add, first is the first fragment, then the second, then the third. Each time you add the number of amino acids that you found, and you calculate the total collected in length peptide. So we could also print that during the for loop to see how it accumulates, but it's not really very useful. Actually, the only thing that we are interested in, what is the final outcome. So the length of the peptide is what we wanted to see, and so we want to print that. And we can give it a comment. And what is the comment? So that's the total number of amino acids, something like this. And the length of the peptide is the variable that we need. And the print command is show me on the screen. And if we do that, we can see that this code works perfectly. Starting from 0, we have gone through each of the fragments. We have added the number of amino acids up, and we get a total of amino acids, which in this case is 15. And that is the principle of how to set up, execute a for loop, and to display its result. In this case, because we are finished, if you wanted to do some calculation based on the number of amino acids, then you could have it and take it from here. And finally, if you're interested where this amino acid sequence here came from, it's the start of a peptide called secretin, which is a hormone secreted by the pancreas. It was discovered in 1902 by Starling and Bayliss at the University College in London.